solve it by means of VLAN. Everyone should have an understanding of VLAN. The different broadcast domains it's referring to are. In the future, broadcasting will not work either. This affects the forwarding behavior of the switch. That is, VLAN is configured on the switch. Due to the configuration of the switch, then you can target different interfaces of the switch, divide it into different LANs, to control future broadcast traffic. The same is true for unicast traffic. That is, from which interface can all the traffic be sent out. They will not transmit broadcasts between different LANs, so it can be isolated. I simply give an example. For example, now I divide this interface into VLAN 10. This interface is also VLAN 10. But this interface is VLAN 20. If this device sends viruses out in the form of broadcasting, then it can be broadcast from this interface. But this interface doesn't work, because they cross VLAN. Different VLANs are different broadcast domains. Packets from different broadcast domains cannot be sent out. This is the behavior control that the switch does. A forwarding behavior of its own. So the broadcast domain we're talking about actually means a delivery range of this broadcast message. So the interface of the switch flooding is the default for broadcast packets. And I tell you, all interfaces of the default switch belong to the same broadcast domain. Different VLANs are different broadcast domains. But unfortunately, by default, the switches are all in the same VLAN. If you want to control it in the future, you need to configure it separately. Okay. What can you understand as a virtual local area network? I configured VLAN on this device. You can understand a VLAN as a virtual switch. I configured a VLAN 10 on these few interfaces. You can understand it as. Now physically you see this switch. It's like cutting it in the middle. For example, the 4 interfaces on the left are assigned to VLAN 10. You can understand that this is 2 switches. It's like cutting the switch in half. This half is a switch. The other half, for example, are all VLAN 20. Although you see it as a device, but actually it has split. You can understand it as a different switch. In fact, there are many ways to divide VLANs. For example, based on MAC. Even IP-based. Including policy-based. But the one we use the most in our projects. VLAN division based on interface. For example, I now have many interfaces on this device. 1 to 48 interfaces. 48 port switch. We can usually divide the 15 interfaces. From 1 to 15 to the technical department. 15 interfaces from 16 to 30 are assigned to the sales department. 30 to 35 these interfaces are divided into the personnel department. The rest will be allocated to the logistics department. Leave 1 or 2 interfaces for redundancy. This is called interface-based VLAN division. Suppose I assign the technical department to VLAN 10. I assign the sales department to VLAN 20. Assign the personnel department to VLAN 30. This is how we divide. We'll do the configuration later. Let's start with the concept. This division is artificially divided by configuration. Pay attention to my words. Artificially divided by configuration. That is, you need to enter this interface. Then divide it into the corresponding VLAN. Then this interface belongs to this VLAN. It's simple. Between different VLANs, unknown unicast data frames can be isolated. Broadcast frames can also be isolated. Data flooding will not pass through different VLANs. Then one might ask. These 15 interfaces are technical department. Then if there is a virus in one of the data or a PC, what about sending to other devices? Okay. They also get infected. But we narrowed down the scope of the infection as much as possible. Originally 48 devices may be infected. Now you have divided the VLAN. Only these dozen or so devices are infected inside. So narrowed down. It's not that you divide the VLAN. There will be no forwarding of the virus. That's not what it means. You need to know. What we have to do is control as much as possible. I mentioned the structure to you before. Access. Converge. Core. VLAN will be configured in the access below. We will configure gateways of different VLANs on layer 3 switches. But there is no concept of 3-layer division VLAN. This is the access layer switch. They will divide VLAN here. For example, this is VLAN 10. This is VLAN 20. In the future, we will be here on the aggregation switch above. The gateways corresponding to VLAN 10 and VLAN 20 will be configured here. But we will not divide the VLAN in the third layer. VLAN is a concept belonging to the second layer. So, this technique is very common in corporate networks. In the corporate network, switching technology is much more common than routing technology. Because every enterprise must have a switch. But each enterprise does not necessarily have multiple routers. This is the application direction of their technology. This is a flexibility of what we call VLANs. That is, between different floors, we can achieve. Different floors can communicate across switches. Let's discuss how VLAN is implemented. I now ask you a question. Port of this switch. Different devices are connected under it. For example, now both of them are not in the same VLAN. Then please. The device on the left acts as a PC. Does it know whether it is in the same VLAN as the device on the right when sending data? Okay. It doesn't know. So for end users, we only guarantee the most basic data communication. Specifically, what VLANs are they? It doesn't care. So when the PC is actually sending data, it doesn't know which VLAN it is in. It is totally unknowable. The operation of VLAN is configured on the switch. It is a technology deployed on the switch. Let's take a look at the process. For example, now PC1 sends a broadcast ARP. Suppose it wants to ask a user on the same network segment 1.2 of this MAC. Because we did not configure the gateway, we will not go to the third floor for now. The device on the left sends an ARP to ask the device on the right. The switch received the ARP data. How does it tell which VLAN it is based on this data? For example, I now assign 1.1 to VLAN 10. 1.2 in VLAN 11. They do not belong to the same VLAN. Then this data should not be forwarded. Although it is an ARP broadcast. But it belongs to cross VLAN. Then how does it know that this data belongs to VLAN 10? Everyone think about this question. The data sent by the PC does not know what VLAN it belongs to. I have to operate on the interface of the switch. That is, data is sent to the switch here. When coming in from the interface, we want to add a tag to this data. It is a field. The above is a standard Ethernet 2 message. A total of 18 bytes. This part is the frame header and frame tail of the second layer E2. Data is the data part. This tag is inserted between the two of them. This type indicates what protocol the upper layer is.